It's not a big deal because it's being thrown straight downward from the top of a 220-foot building. So that would be my SO. Initial velocity is going to be negative 22. Sometimes they say 22, but since it's being thrown straight down, you have to know that that means it's going to be negative. The only thing that we seem to be missing is acceleration. All right, so I need to figure out what acceleration would be, and that's just a fact. Acceleration in this case would be only related to gravity. And because our units are feet, we would want gravity that takes into account feet rather than meters. Right? You work in physics with meters per second squared very frequently. And that's your 9.8, negative 9.8. What is it in feet? It will become negative 16, but before that, negative 32 feet per second squared. It's just when it gets plugged into the position function and multiplied by the 1/2, the negative 32 becomes negative 16. But the gravitational constant is actually negative 32 feet per second squared. All right, so we'd be looking at, I'll write it out, 1/2 times negative 32 t squared minus 22t plus 220. And you can clean it up. Negative 16t squared minus 22t plus 220. V of t is really just asking you simply to take the derivative, and that is what? Negative 32t minus 22. Now, your velocity at 3, you could go a couple of different ways. You could use numerical derivatives in your calculator, or you could just plug and chug. Negative 32 times 3 minus 22. So negative 96 minus 22, negative 98, negative 118. And the units there would be feet per second. We don't need units for functions, we need them for numbers. All right. All right, D is not, it's not really a throwaway question, but it's more to kind of lead you to E. Find the position, aka the height off the ground, after falling 108 feet. All right, well, you ready for it? Started at 220. Yeah. Whoa. Some serious calculus just happened. It's crazy. Above ground. Okay, so that seemed like, whoa, where did that come from? I had a reason for it. And the reason has to do with a complete lack of fundamental understanding of what a coordinate is on all levels, right? So this is freshman all the way through third semester calculus, actually even beyond that. So I have a coordinate here. That coordinate we think of as xy. That x, I mean, when you plot a point, we typically think of it as movement along the x and then go up and get your y, or go down. Right? That's not at all what it is. That's just how you've been taught to plot a coordinate, because you need some sort of structure in how you do things. Right? The x is the distance in general from the y-axis, while the y is the distance from the x-axis. All right? At any part of either axis. All right? Not necessarily the origin. Right? And so that's the common misconception. Why is that important? Well, in this case, we're working with t's and s of t's. Whenever I define a function, the t taking place of the x would be the distance from the s of t axis. the s of t would be the distance from the t-axis, right? But more importantly, if we know that we're dealing with axes, that t-axis here is when your s of t is equal to 0, all right? So along this axis here, s of t equals 0. Along this axis, I can't draw. T equals 0. All right. Why is that important? Well, it's important because it tells me that when an object is falling 108 feet, that is not going to be our s of t. All right. S of t has to be the distance from ground level up. All right. That's kind of like if a person was running for a period of 5 seconds. You would like to know when that 5-second clock started. You know, what if they had already ran for 20 seconds? I mean, are they starting from time t equals 0, or are they starting from time t equals 20? You know, what's the story there? So in this case, you kind of need to know the rules of the game. But these were always the rules of the game. It's just people have asked in the past, well, how do I know that that's not my s of t? Well, it's not because it's not. That's just not how it works. All right, that's not the rules of the game. All right. So, that being said, there are some shortcuts, but we'll address that in a minute. So, my position would be at 112, with my function being negative 16t squared minus 22t plus 220. Then I would solve. All right, but then that 108 comes back into play, which is really interesting. And it's interesting because gravity is not changing, right? Gravity is constant. Regardless of whether I actually figure out the second derivative and verify that, we know gravity is unchanging. So if that's the case, then this position function would have the same relationship no matter where you start. Right, so whether you're starting at 220 feet or you're starting at 108 feet, it's still going to have the same properties. All right, but anyway, another program that you have, quadratic formula, takes away any need to do the math on this. That's not an 8. In this context, the negative doesn't make sense, so t is equal to 2. And then I just need v of 2. So negative 32 times 2 minus 22, negative 86. And also possibly not doing it during the pledge. I mean, if we want to continue that. First derivative is the what function? Which is denoted as s prime of t. All right, so s prime of t would be the derivative of this wonderful looking position function. In general terms, we would say that it's equal to what? What's at plus vo? All right, second derivative would be what? Acceleration. And that derivative would be what? Just a, yeah. Kind of funny how that works.
For the velocity function, if I write v of t instead of s prime of t on a test, would that be okay?
Yeah, perfect.
Okay.
Yeah, as long as you do the right thing with it.
Okay.
So The next part of the process boils down to whether you're allowed to use the calculator or not. All right, so we have a velocity function. Now, if we're allowed to use the calculator to get acceleration, it could just be as simple, let me just pop in my velocity function. Could be just as simple as using my y4 or possibly the math 8, it's up to you. But since my y4 is set up to be my derivative, that seems to be the better way to go, all right? So, because again, the derivative of acceleration is, velocity is acceleration. So, if I'm looking for the velocity and acceleration at 1 second, I might do this. All right, I'm going to set my table to start at 0. Oh, I had my y4 off, so that's kind of important. If I want y4 to show up in my table, you may want to turn it on. So hit enter on the equal sign, and then go from there. All right, so it's reporting a fraction for the first calculation just because it can. For the second calculation, it's saying that the fraction is so complicated that it's not worth writing it down as a fraction, or it's not something it can report as a fraction, all right? But I can say 45 over 7, 45 over 7, yeah.
How did you get it to report as a fraction?
If it's in this form when you type it in, then it should automatically show up as a fraction if it can be converted to fractions. Sometimes that's annoying because sometimes you want the decimal and it automatically puts it as a fraction. You have to do the extra step. But, I mean, as inconveniences go, it's not the worst. Feet per second would be our units. And then 4.592 feet per second squared. All right, units are very important here. All right, anything that involves context, you need the appropriate units, otherwise, you know, points. 5 is nice, 15 and 1. Then I would have to scroll down to 10 in order to come up with the last one. So 18 feet per second and 0.36 feet per second squared. All right. So what would we say is happening here as time increases? Two ends in happening? Go for it.
No.
No, now it looks just terrible.
Yeah, that looks right.
It looks right-er.
I think what is right?
Oh boy.
Yeah, happened means
Oh,
weird.
yeah, that's right.
That's supposed to be for the 0.36.
That's supposed to be, say it again?
For it says V of 10 twice.
Oh, thanks. All right, so let me just do it maybe, oh, it actually worked. Okay, I can live with that. Okay, so what is, oh geez, that's killing me. And it won't even let me erase it now. All right. What's going on? Oh, doing all right. You know, good Halloween, a lot of candy. All right. So, what's happening in this situation?
The velocity is increasing, but the rate at which the velocity is increasing is decreasing.
Okay, so velocity is increasing, but the rate at which velocity is increasing is decreasing. All right. Now, that's a perfectly acceptable way of saying it. College Board is a big fan of taking it and putting it into simple language, everyday speak. So now, which is kind of weird because if you were to give an ordinary person these numbers and then expect them to not know the words velocity increasing and decreasing, then I think that would be unrealistic, but I think they're very often unrealistic. So here we go. So if you were to say this in simple terms, like you're driving a car, what's going on?
You're speeding up, but you're not speeding up as much as you were before.
Exactly.
Is that simple terms?
That is simple terms.
Both would be fine.
Depends on the question. All right, that's it's kind of weird, but that's an example of a soft skill. All right, being able to take something that is kind of textbooky and putting it into words that an ordinary person would understand. All right, so that, if you create an analogy that an ordinary person could relate to, then that's a good step in the right direction. So that's what I was saying. It's a car. They gave us the idea that it was a vehicle. But even if it wasn't, if you're talking about an object in motion, you could say, for example, if you're in a car and you're at a stoplight, the light turns green, what do? You speed up. But then once you reach whatever speed you're trying to get to, your acceleration would reduce. So the rate at which you're speeding up would slow down. So this would be a good idea of a good way of getting that idea across. All right. So either way you should be prepared for, but depending on the way a question is phrased, you may have to go in one direction as opposed to another. All right. And also, just think, was it Einstein? It was something like, if you can't explain it simply enough, then you really don't understand it. Or if you can't explain it in simple terms, then you really don't understand the concept. So try to do stuff like that, because if you kind of make it like you're trying to explain it to somebody who doesn't have any background in calculus, that if you could explain the idea to that person, then that means you have a pretty strong grasp of what's going on. More than pretty strong, incredibly strong.